Alright guys, let's knock out this week's homework. This first one here, we're testing all these, see if they're right triangles. So on each one of these we're doing the two shorter sides squared, added together, and seeing that's equal to the longer side. So 9 squared plus 12 squared, we need to see if that's equal to 14 squared. So if I put in my calculator, 9 squared plus 12 squared is 225. But 14 squared is 196. So this one is not a right triangle. Alright, the next one here, 16, 30, and 35. So 16 squared plus 30 squared. Let's see if that's equal to 35 squared. So we have, nope, about 60 off. So this one's also not a right triangle. Next one here, 10 squared plus 10.5 squared. And that's supposed to be equal to 14.5 squared. Yep. Those are the exact same. So we do have a right triangle for this one. I'm going to say yes, that is a right triangle. Well, square root of 3 squared and square root of 13 squared. That's going to be 3 plus 13, which is 16, and 4 squared is 16. So yes, this one is. I don't even need a triangle for that one. Let's see, the last one here. Square root of 50 is just slightly more than 7. But this would be 50 plus 50 when we square them. That's 100, and 10 squared is 100. So yes, this one is also a right triangle. Alright, so we have 3 here that are right triangles, 2 here that are not. Alright, down here on number 2, it says a right triangle has a hypotenuse of 15 centimeters. What are possible lengths for the two legs of the triangle? Well, we could make it easy and say that they are square roots. We could say this would be like square root of 11 and square root of 4. We could write square root of 4, or we could say 2. Right? As long as we can. Wait, that's not right. Sorry. 15 squared is 225. So we need the numbers added to 225. So scratch that. That didn't make any sense. So it could be like the square root of 200 and the square root of 25, which is 5. Alright, so that would work. There's tons of possibilities, right? As long as when you square these two and add them together, they add to 225. Then we know it. Those are possible side lengths for that triangle. In each part, A and B represent the length of the leg of a right triangle, and C represents the length of its hypotenuse. Find the missing length. So if we have A and B this time, so let's do 12 squared plus the 5 squared. So that's 169. So now we do a square root of 169. That's 13. So that means the hypotenuse this time is 13. Now to find A, it's the same idea, right? But we're not adding these two together this time. We're actually going to square this one, take that one away, and then that'll give us A squared. So let's do a little quicker here in our calculator. 29 squared minus the 21 squared. So we're doing C squared minus B squared. It's 400. The square root of 400, 20. So this time A is 20. And one more. Oh, no, that was it. Alright, so 2 points for that one. For which triangle does the Pythagorean theorem express the relationship between the lengths of the 3 sides? B. Hopefully. You know that because it's the right triangle, right? Pythagorean theorem only works for right triangles. Alright, so we need to remember that. Alright, one more question. Excuse me. Andre makes a trip to Mexico. He exchanges some dollars for pesos at a rate of 20 pesos per dollar. While in Mexico, he spends 9,000 pesos. When he returns, he exchanges pesos for dollars. Still 20 pesos per dollar. He gets back 1/10 the amount he started with. So we're supposed to figure out how many dollars Andre exchanged for pesos. Alright, so let's write this in an equation. So it looks like dollars is our variable here. So 20 pesos per dollar times the number of dollars minus the 9,000 he spent. Alright, so this is how many peso, or how many dollars he actually had, divided by 20 to turn that back into, I'm sorry, that's how many pesos he had, divided by 20 to turn it back into how many dollars he had. And that's going to be equal at the end to the number of dollars divided by 10, because he has 1/10 left. Alright, so then if we solve, maybe divide by 20 here, 20x divided by 20 is x, 900 divided by 20 is 450, that's x over 10, so I guess we can multiply this by 10, so that's 10x minus 4,500 equals x. I guess we can subtract x and add 4,500. Subtract an x here and here, add 4,500 here, and add 4,500 here. So we have 9x equals 4,500, divide by 9, so x equals 500. That means he had $500. Alright. Alright, side 2. Still more Pythagorean theorem. Now we're talking about some problems here, some real world problems. Except for this is zombie proofing a house. Cuddling to wood will brace a door against a wall. The picture pretty much shows us everything we need to know, though. The wall is 4 feet away from the door. Right here. He wants it to be 2 feet high. Alright. So we want to figure out how long that brace needs to be. So that's just going to be 2 squared plus 4 squared equals c squared, right? This is c, this is our hypotenuse, there's the right angle. So 4 and 16, so 20. So the square root of 20 is c. And you could estimate if you wanted to. That's between 4 and 5, probably 4.4 or so. But I'll just leave it like that. Have an exact answer. Alright. At a restaurant, trash can's opening is rectangular, measures 7 by 9. The restaurant serves food on trays that measure 12 by 16. She says the trays can't fall through because the shortest edge here, 12, is still longer than the width of the trash can. But that's not taking into account how wide the trash can is. So the trash can, let's say it's here, even if it's 7 by 9, and the tray, right, is wider than that, it's 12 by 16, but that's not, if this part here, if this 12 could fit into through this way, then it could still fall into the trash can. So we need to figure out if that hypotenuse here is going to be bigger or smaller than 12. So, let's just check in our calculator here. 7 squared plus 9 squared is 130. I know that's going to be a little bit bigger than 12 because, oh, whoops. Sorry, slightly smaller than 12. 144 would have been the square root of 12, right? So that opening, this opening right here is 11.4, which is still slightly smaller than the length of that tray. So now that tray is still not going to fit through there. Select all the sets that are 3 sides of right triangles. Alright, so this one here, our longest side must be C. So let's see if 8 squared plus 7 squared is equal to 15 squared. Nope. Not the same. So that's no, not a right triangle. The longest side this time, it looks like, is actually the 10. The square root of 84 is just slightly bigger than 9, but it's going to be less than 10. So we have 16 plus 84 is 100, and then 10 squared obviously is 100 as well. So this one is a right triangle. So that one should be selected. Alright, continuing at the top of the next page. So it looks like we have 8. Square root of 8 squared is 8 plus 11 squared, 129, and then that's going to be 129 squared. So this one is also a right triangle. Those two shorter sides add up to make the longer side. Square root of 1 squared, that's 1, plus 2 squared is 4. Oh wait, that's actually bigger than the square root of 3. So I did it wrong there. This is actually the C, this is the hypotenuse here. So 1 plus 3 equals 2 squared, which is 4. So that's true. So yes, this is a right triangle. So let's circle that one as well. For each pair of numbers, which of the two numbers is larger? How many times larger? Well, this one here is pretty easy. The exponents are the same, so 12 is just 3 times larger. So I'm going to circle the larger one and say 3 times larger. Again, the exponents are the same, 1.5 and 3. 3 is 2 times as big as 1.5. This time the exponents are not the same. So this is, what, this one here is 10 times bigger with just the exponents. Alright, we'll multiply by an extra 10. But the 6 is smaller, so we have to factor that in as well. So we could divide that by about 3. 18 divided by 3 would be 6. So instead of being 10, it's going to be closer to 3 times larger. Alright. The line contains the points 3, 5. The line has negative slope. Which of these points could also be on the line? So let's say here's the origin here. Go right 3 up 5. That's 3, 5. Then 2, 0 would be here. That would be a positive slope. So that one didn't work. 4, 7 would be up here. So that doesn't work. That would be a positive slope. 5, a little farther and a little farther down, would be a negative slope. So 5, 4 there is our correct answer. Whoops. Alright, so there's 5, 4. That would be a little bit below and a little bit to the right, which would make a negative, a decreasing line there. Alright, a little more. Noah and Han are preparing for a jump rope contest. Noah can jump 40 times in 0.5 minutes, so 40 times in 30 seconds, so twice that many times in 1 minute. So Noah can actually jump 80 times in 1 minute. Han can jump 78 times in 1 minute. They both jump for 2 minutes. Who jumps more? How many times more? So in 2 minutes, this would be what, 160 for Noah, and Han 2 times the 78. That'd be 4 less. That'd be 156. So Noah can jump more. Noah does 4 more jumps. Alright, get that finished and get it turned in by Friday, please.